A Brief History of AI, Part 3 in a 14-part series. The whole conversation around AI started in 1950 when computers were beginning to enter the business world. Allen Turing, one of the early pioneers of computing technology, was asked repeatedly whether these new thinking machines could really think. His response was his 1950 paper titled Computer Machinery and Intelligence. He begins the paper with, "I propose to consider the question, can machines think? This should begin with the definitions of the meaning of the term machine and think." He goes on with, "The new form of the problem can be described in terms of a game, which we will call the imitation game. I believe that in about 50 years' time it will be possible to program computers with a storage capacity of 10 to the ninth to make them play the imitation game, in other words, trying to determine whether the person on the other side is a human or a computer, so well that the average interrogator will not have more than 70% chance of making the right identification after 5 minutes of questioning." He concludes with, "The game may perhaps be criticized on the grounds that the odds are weighed too heavily against the machine," which indeed it was. It didn't take 50 years, it took 67. The next big advance was in 1966 with the invention of the ELIZA program, a first attempt at natural language processing.
ELIZA is a computer program that anyone can converse with via the keyboard, and it'll reply on the screen.
He says, I'm depressed much of the time.
I'm sorry to hear that you're depressed.
It's true. I am unhappy.
Do you think coming here will help you not to be unhappy?
So ELIZA is a program operated within a time-sharing system at MIT, which makes certain kinds of natural language conversations between man and a computer possible. The system described so far is essentially one which selects a decomposition rule for the highest ranking keyword found in the input text, attempting to match that text according to the decomposition rules, and, failing to match, selects the next reassembly rule associated with it. In other words, it does not really understand what is being typed, but rather just tries to plug words into recognized patterns. He concludes with, "Seen in the coldest possible light, ELIZA is a translating processor in Gord's sense. However, it is one which has been especially constructed to work well with natural language text." Next, in 1967, the MYCIN program is created. MYCIN is a rule-based expert system which uses artificial intelligence techniques and is a model of the interaction between physicians and human consultants to attempt to satisfy the demands of a user community that is often reluctant to experiment with computer technology. The important thing to note is MYCIN is an expert system. It is not an AI like modern systems. In other words, it does not learn. It is only programmed to represent existing human knowledge. Interestingly, this paper also defines AI. It's a subset of computer science in which the emphasis of the research is on symbolic reasoning rather than numerical computation. MYCIN is a Lisp program designed to serve as a clinical consultant on the subject of therapy and selection for patients with infections. Note that Lisp is a program designed to capture human knowledge, not do computation like traditional programming languages are designed to do. What followed was a kind of dark ages for AI. We had to wait 21 years before the next significant advance, when IBM's Deep Blue challenged the greatest chess player who ever lived. On May 11, 1997 in New York City, the upgraded Deep Blue entered the match with a large excited audience. Kasparov won the first game, but Deep Blue took the second, tying the players. Then came 3 games that ended in draws. In the 6th game, Kasparov made a mistake in the opening.
Deep Blue was just sitting there and just keep on attacking, just moving pieces around. And he knew he was in trouble.
But at the end, Kasparov he stands up, he starts gesturing, he looks over at his mother. I think having your mother in the room where you're playing an important chess game is not a great idea, as much as I love my mom.
I was dumbfounded and elated at the same time.
Deep Blue won that 6th game quickly, winning the match, much to the astonishment of the crowd. Kasparov claimed to have perceived a human hand in Deep Blue's play. Kasparov went on to say, "And for the first time in the history of mankind, I saw something similar to an artificial intellect." Note that Deep Blue was not a learning program like today's modern AI. Instead, it simply memorized rules that were given to him by human players. IBM's Deep Blue success marked a turning point in AI research. Future advances will not use expert systems with specifically trained rules and logical patterns. Instead, they'll use neural networks. The first to demonstrate this power is Dr. Watson and the Jeopardy player.
This is Jeopardy, the IBM challenge.
Watson.
Who is Franz Liszt?
You are right.
What is violin?
Good.
Who is the church lady?
Yes. A total of 77,147.
Named after IBM's first CEO, Watson is a question-answering computer program developed by IBM research team. It was the leading edge in a new generation of computers capable of understanding questions posed in natural language and answering them far more accurately than any standard search technology, without being connected to the internet. Watson's ability to uncover insights in unstructured data represented a big leap in the subset of artificial intelligence called natural language processing, and an important step towards a world in which intelligent machines are able to understand and respond to everyday questions to improve decision-making. Just 3 years after Watson, a small team in Princeton University attempted to pass the Turing test, and they did this with a creation called Eugene Goostman. Eugene Goostman is a chatbot masquerading as a 13-year-old Ukrainian boy with a notably short attention span. Eugene thus became the first in that competition to meet the criteria of the imitation game for artificial intelligence, suggested by cybernetics pioneer Allen Turing in 1950. The test is simple. Converse so naturally that human observers think they are talking to another person. The next chapter of AI development had an odd twist. In 2016, Google DeepMind developed a program to play the ancient game of Go.
Go is the world's oldest continuously played board game. It is one of the simplest and also most abstract.
Everything we've ever tried in AI just falls over when you try the game of Go.
The number of possible configurations of the board is more than the number of atoms in the universe.
AlphaGo competed against the legendary Go player Lee Sedol, winner of 18 world titles and widely considered the greatest player of that decade. AlphaGo's 4-1 victory in Seoul, South Korea in March 2016 was watched by over 200 million people worldwide. This landmark achievement was a decade ahead of its time. Lee Sedol later said, "I thought AlphaGo was based on the probability calculations and it was merely a machine. But when I saw this move, it changed my mind. Surely AlphaGo is creative." Now, AlphaGo was taught to play Go like a traditional program. Basically, it was taught the rules that humans use. Now, AlphaGo was taught to play the game of Go like a human. In other words, it was taught with human strategies and with human perspectives. But the DeepMind team wasn't satisfied with that, and shortly after their victory, they threw everything away and started from scratch. They started with a blank neural net that didn't know anything about the game of Go, and it started playing itself. In just a few hours, it learned the rules of the game. In a couple days, it learned the primary human strategies. Then it did something interesting. It threw away the human strategies because it had found that they were flawed, and it developed its own. After 40 days, AlphaGo Zero surpassed all other versions of AlphaGo and arguably became the best Go player in the world. It does this entirely from self-play, with no human intervention and using no historical data. Fresh off their success from AlphaGo, DeepMind decided to apply the same type of approach to a more practical application, and this application is protein folding. And this is a critical biological process where a linear chain of amino acids folds into a specific, stable, three-dimensional structure. It's important to understand these structures so we can know how proteins work, but it's also very difficult for a human or even a computer to compute. So DeepMind is known to have trained the program on over 170,000 proteins from a public repository of protein sequences and structures. The program uses a form of attention network, a deep learning technique that focuses on having the AI algorithm identify parts of a larger program, then piece it together to obtain the overall solution. In just a few short years, AlphaFold has predicted over 200 million protein structures, nearly all catalog proteins known to science. And the final big milestone in AI is the introduction of ChatGPT. This is the first time ever that cutting-edge, state-of-the-art AI is available to the general public. And as you, of course, know, it has transformed the world. The rate of innovation has been accelerating. What's the next few years going to look like? I just cannot wait to find out.